Okay, you guys, welcome back. Hope you had a nice weekend. Hello. We're going to start today learning how to use processing, mostly because it's a lot like C++ and it's fun. So we'll see how we can, we'll see what we can do with it, see what some of you guys can do with it by the end of the semester. This is, as I mentioned before, I got the idea for using processing from a guy in the art department, Justin Lincoln. And I've come to look at programming and processing in particular as, you know, in a liberal artsy kind of way, as a medium for expression. You know, you learn how to paint or you learn how to draw, right? And that's a skill. And through that skill, you express yourself somehow. There's a really growing, a burgeoning movement out there for people expressing themselves artistically through programming. And you guys now are at the point where you have the skills necessary to begin to express yourself artistically through programming. And I feel like there's a nice symbiotic relationship between me teaching you how to program and you playing a little bit with the expressive side of programming. So that's what we're going to do for the remainder of the semester, and we're going to start very simple, drawing really simple shapes and understanding the coordinate systems. We're going to get up to a point where you'll actually be able to build objects and build classes and objects and create sketches. That's what processing programs are called, sketches, that are interesting and fun maybe. Why are there crutches back there? What happened?
I running on first baseline and busting up my ankle.
Are you going to be able to play anymore, or are you done?
I don't know.
Okay. That's too bad. You were were you guys in Salem this weekend? Okay. I was in Salem too. That's where my conference was. And I didn't realize it until after I got back here that you guys were there too. Oh well. Anyway, so first things first, you need to go to processing.org and grab the program. It's a free program. I think it's developed by some guys at MIT or something. So you go to processing.org, you go to download, and down here are various links for various platforms, Windows, Linux, and Mac. Danielle says that Mac doesn't quite work as it is. So if you're having trouble getting it running, come to me and I'll help you out getting it up and running on your computer. That said, I'm not going to go too far in that direction. I've installed it in the lab, and so if we can't get it running on your computer, you have the math lab. So it is now in the math lab, and you can try it there. I've already done this. I clicked on the 64-bit version and downloaded it and installed it, and it'll drop an icon on your desktop, at least in Windows, called Processing. And if you click on that icon, it'll pop up its little development window. So it's very straightforward. The program you type in here. So we're not going to be using VI. I can show you how to use VI or Vim in conjunction with this, but I'm not sure that it's worth it at this point in the semester to figure that out. So we'll just use the built-in editor. And you'll remember that your process for writing a program is to open a file with Vim, type some stuff into that file, and then compile it with G++, and then run the resulting binary a.out or whatever you decide to call it. Processing has actually sort of bundled all of that stuff into one application. So you type your program here in this empty window, and you press play, and your program will run. And you press stop, and your program will stop. And that's it. What you're going to submit to me, let me write a little program here, set up. let's just make an ellipse. So I have written a very simple processing program here. Let me save it. If I just click play, it's going to ask me where I want to save it. Oh, and I'm using the JavaScript version, and I don't want to do that. Cancel. Just ignore this part. Oh, I guess I better save it. All right, so you save it. I keep all of my stuff in a folder called Sketchbook. That's what processing is going to do for you. You can just take the default location and it'll create this folder called Sketchbook, and then you can type the name. So this is just, I'll just call it ellipse, and click Save. So now it's saved. Now I'll switch over to Java mode. That's not something that you have to do. And press play. And there is a little 200 pixel by 200 pixel canvas with an ellipse centered at 100, 100 of width 30 and height 30. So an ellipse whose width is the same as its height is a circle. Now that's going to create, having saved this file, I need to show you what to do with it. So you've got your sketchbook. I keep mine in my Dropbox folder here and here. The thing that I want from you is this .pde file. So you would go to the class web page. Yes. Go to the class web page and click Upload Homework. And choose a file. And I'll go to my sketchbook folder and my ellipse folder, and I'll grab that guy. And then I'll punch in my user ID. And I'll associate it with something else and click Submit. And that uploads the .pde file to me. So that's the equivalent of you uploading your .cpp or your .h file. Now it's a .pde file, and I think it stands for Processing Development Environment or something. And then once you send that to me, I can actually load it into my own processing program and check it. Okay? Okay. So let's go back here and look at what's going on. It's a little different from C++. There's no includes, there's no main. So we'll have to get used to that a little bit. How do you learn about processing? Just go to the links that I've provided here. And I'll keep providing links as they become relevant here. If you go into the homework assignment, I give you the links to look at. And I want you to work through these two pages this week, the introductory tutorial and coordinates and simple shapes. So if you click on the introductory tutorial, it just walks you through what this little environment is all about and sets you up with your first program. And you just keep reading through and you learn all about the interface. And then if you go to coordinate systems and simple shapes, which is what I'm going to talk about today, it describes how things are located on the processing canvas. All right.
If we're doing a static picture, do we need the void setup?
As opposed to
Just not having, because it'll still run.
yeah, I think you can do it without setup. I was just kind of introducing. Let's try to get rid of it. I've never actually tried that, Danielle, but it might work. Yeah, it's fine. So the simplest possible processing program is probably right here. You set the size of the canvas, you draw an ellipse. In fact, yeah, let's just keep working in that. Okay. So let's talk a little bit about this size thing and the so-called coordinate system. I want to get up some notes here. All right, the processing coordinate system. And it may, for some of you who haven't had math in a while, this may be a real blast from the past. You remember way back in, I don't know when you first did this, maybe 8th grade or something. If I had a point like 1, 2, what that meant was go out 1 unit on the horizontal axis and go up 2 units on the vertical axis. So that would mean go 1 unit here and then 2 units, and that's the point, 1, 2. And we all learned that, and we have that coordinate system ingrained in our heads. In computer graphics, the coordinate system is a little bit different than what we traditionally learn in 8th grade. So this is the old 8th grade algebra coordinates. Let's look at computer graphics coordinates. So the way computer graphics work is more like this. This is the origin, 0, 0. And then this is the positive x direction. And this is the positive y direction. Very, very different from the 8th grade coordinate system. In particular, that y-axis going positive is down now instead of up. That's very different. Causes no end of confusion for people when they first start out in computer graphics. So the horizontal axis is exactly the same as it was in 8th grade. The vertical axis has been flipped upside down.
So it's starting like basically in the top left corner.
And it starts from the top left corner, exactly. So the canvas, this is the canvas. That's the viewable area. So when I do a 200 by 200 canvas, what I have is a roughly, well, precisely square canvas. And let's get that in there. And there are 200 in this direction and 200 in this direction. 200 what is the question? Yes. Unlike the old 8th grade algebra system, for example, we knew how to plot 1/2 and 2, right? We would go out 1/2 in the x direction and 2 up in the y direction, and it would give us this guy here. We don't have fractions on the new graphical coordinate system. The coordinates are always integers. So there are no, they're all integer coordinates. No fractions. That said, if you make a mistake and you feed it a fraction as a coordinate, it'll just round it up or round it down however it wants to, and it'll put the pixel there. That's kind of convenient. Okay, so a pixel is the smallest possible piece of a canvas. It's like the atom of a canvas. And pixel coordinates for our 200 by 200 canvas, the coordinates go, you'll not be surprised to learn, from 0 to 199 in the x direction, and 0 to 199 in the y direction. Why is that consistent with what we've done? That's how arrays work, right? Arrays start at index 0 and go up to size -1. You'll not be surprised to learn that a canvas is really just a big two-dimensional array. So that's why the indexing thing works the way it does. All right, that's the coordinate system. Once you know about the coordinate system, you can start placing basic shapes on the screen if you understand the syntax. So let's talk about the first basic shape. Is the ellipse. And we use ellipse because, yeah, it's great to draw circles, but you might also want to draw ovals. And circles are really just specific instances of ovals. And so instead of providing a circle command and an ellipse command, we just provide an ellipse command, and we rely on the user to figure out how to make a circle out of that. So an ellipse has 4 arguments: the center of the ellipse, and the width in the x direction, and the width in the y direction. So this is the center pixel, and these are the widths. If these widths are equal, when width x equals width y, then you get a circle of radius width x. Width of what, you might ask? Well, the way that this works is you're essentially specifying a rectangle and then sketching the ellipse inside there. That's a terrible ellipse, but you get the idea. This is width y, and this is width x.
Then wouldn't it be the diameter of the x? The circle would be a diameter.
Yes, good call. Okay. The lameness of that drawing aside, everybody understand what we're doing here? Okay, let's see it in action. So here I get myself a canvas of 200 by 200 pixels, right? So how many pixels is that? 40,000. It's a lot of pixels. Okay, 40,000 pixels. What this command is going to do is put the center of the ellipse at 100, 100, which is approximately the dead center of the canvas, but not quite, right? Not quite, Kendall?
What happens when you have 2 different values for the x and y center pixel? Like one is at 5 and the other is at 20.
Yeah, well, let's do that. So let's make this 50 and that one 100. Is that what you mean?
Yeah.
Okay. So what's different? It's closer to the left-hand side, right? And the left-hand side is where what? That's where x is 0, right? That's where x is 0. And the right-hand side is where x is 199. So we could try that. We could change this to 199. Oops, got to stop it first. Come on. And we see that only half is visible. So half of the ellipse is outside the canvas. It's actually still there, that piece that we can't see. So you can think of the canvas as just the part that you can see, but it's perfectly safe to paint outside of the canvas. You just won't see it. Go ahead.
So you could you change that 199 value to something over that? Or
Absolutely. I could make it like -100, -100. And then it would be, up here somewhere. And we wouldn't see it, but it's there. Yeah. Okay. Let's play around. Let's put it back at the center. Good. And let's play around with this thing. So if I change that to, say, a 15, look at the picture here. So now width y is 30 and width x is 15. I get an oval and the long axis is vertical, right? So let's see that. And there you have it. We could make this a little bit bigger, I suppose. Say 50 and 100. And you see that the magnitude of the width is what controls the size of the ellipse. There are other elements, other simple elements that you can draw. For example, you could draw a rectangle. Rectangle's a little bit different. So rectangle gives the upper left x coordinate, the upper left y coordinate, and then the width in the x direction and the width in the y direction. And you have to learn all these basic shapes. You have to learn what the arguments describe. So unlike the ellipse, you don't specify the center of the rectangle and the width in the x direction and the width of the y direction. You specify the upper left-hand corner of the rectangle and then the width in the x direction and width in the y direction. It's just different. So this is the upper left corner. And let's see how that works. Maybe we could try to put a rectangle. Let's just put it next to the ellipse for now. So let's see here, 100, 100. So what is the x coordinate of the furthest point to the right of this ellipse? 150? 150. 149? Somewhere in that ballpark. So we'll start our rectangle there at 150 in the x direction. What about, doesn't really matter in the y direction, we'll just put it at the same level as, say, the top of the ellipse, which would be like 50-ish. And then let's make it, I don't know, 30 wide in the x direction and 40 wide in the y direction. And you can put as many shapes up there as you want. You could do a for loop, for example. Let's do I times 15, say, and I times 15. Let's try that, and then let's do, say, 20 wide and 20 high. So now I can start generating numerous rectangles using loops, for example. Okay, let me pause there and let, I forget who's up today. Kyle? No Kyle? I don't even know if Kyle's still in this class. Okay. No? Okay, then I'll stop. And, or I won't do that. He was gonna do, he was gonna talk about the singularity, which is an interesting topic. But no, next time Ami though, right? Okay. And then maybe Friday, Rachel, if she's feeling well. Right now she's not feeling well. Okay. So we can now start pulling in some of the algorithmic techniques from C++, like loops and if statements and what have you, to generate more complex figures, right? It would be really arduous to put that many figures on the canvas one command at a time. But you can call these loops and systematically generate figures. All right, let's see here. Another basic figure that's available to us is a line. So let's get rid of these guys. And let's do just a line. Line. And the way that line works is it takes 2 points and it draws the dot, it connects the dots. So let's draw a line from the upper left-hand corner to the lower right corner. Simple enough. Let me make a note of that here. So the line goes from point 1x, point 1y to point 2x, point 2y, and it just connects the dots. And it doesn't matter what order you put it in, right? You could put P2 first and then P1, and you're going to get the same line. And you can do systematic kinds of things with lines as well. For example, let me see if I can do this. For I equal 10, I less than or equal to 190, I plus equals 10. Okay, what do I want to do? I want line I0 connected to, okay, that's going to go across the top. Let's go down the left-hand side. 0, 190 minus I. Anybody know what that's going to give me?
What does I plus equals 10 mean?
It means go 10, 20, 30, 40, 50.
Is that going to give you lines that are parallel? There's like space like.
So across the top, go ahead, Andrew.
We'll do line at the top, and then I'll do all the way up to this.
It's something that like probably all of us have doodled at some point in our careers. You start with this line and then this line and this line and this line, and it traces out a hyperbola. Do you remember that, or have you done that? Yeah, we've all doodled that. Oh, I have a typo. I forgot to declare I. just like C++, you've got to declare your variables. And you can see the comment here, can't find anything named I. That's how processing tells you that you forgot to declare something. And there you go. I don't like that other line in there, so I'm going to get rid of it. They're not curved. It's a bit of an optical illusion, really, but those are all straight lines. The first line that is drawn by this loop starts at 10, 0. That's right here. X equals 10, y equals 0. And goes down to 0, 180. So that's 0, 180. That's down here. So that's a straight line. That's the first one. There's the second one, the third one, the fourth one, the fifth one, all the way up. All straight lines. And that apparent curve is a hyperbola. What if I wanted to get a complementary one in the lower right-hand corner? How might I tweak this? So I'm going to keep the lines at the top, and what I'd like to do is put a complementary set of lines in the lower right corner. See if you can think that out. So remember that the I0 here corresponds to the x coordinates that go across the top. What we'd like is x coordinates that go across the bottom, right? How do we make those x coordinates I0 that are going across the top, how do we make them go across the bottom? How do I tweak I0 to make it go across the bottom? I have to change the y coordinate to 199 and leave the I coordinate the same. Yes. All right. Now, at the same time that these guys were going across the top, these guys were starting where? At the bottom and moving up the left-hand side. Now we would like the y coordinates to start at the top and go down. Sorry, no, we wouldn't. Now we'd like the y coordinates to start at the bottom and go up over on the right-hand side. How do I make that happen? So the direction is the same. I misspoke. They start at the bottom, they go to the top on the left. How do I make them start at the bottom and go to the top on the right?
Plus.
Change the x coordinate to what? 199. And that moves all those points that were previously going up the left-hand side, makes their x coordinates 199. And so now they all go up the right-hand side. Let's see if that actually works. Sure enough. So this is the kind of stuff that we want to get comfortable with this week. Thinking in coordinates, thinking systematically in coordinates. My assignment for this week is pretty free form. Draw me a static picture in processing. That's it. And then write an animated sketch in processing. We're going to talk about how to make these things animated next time. Maybe this time. But what I want to do right now is show you all of the kind of available things that you can do with a static sketch. So right now we've shown you ellipses, we've shown you rectangles, and we've done lines. Let's talk a little bit about color. I've been using the default colors so far in processing. And there are two concepts that we want to get used to here. Fill and stroke. So fill is the color that objects are filled with. The default, can you guess? Actually, you can't guess from there, but the default is white. Remember when I drew that ellipse, the interior was white. The default is white. And you can turn it off with what's called the no fill command. And there's stroke. And that's the color of outlines of objects. And the default is black. And you'll not be surprised to learn that no stroke turns it off. Let's fiddle around with that a little bit. So here's my hyperbolic illusion. Let me stop it here. The way that fill works, or the way that stroke works, at least to start off with, let's keep it simple. Let's do fill 100. And see if you notice the difference. Sorry, not fill. We're drawing lines, so we're doing stroke. Lines don't have an interior, they're all stroke. So what do you notice? It's gray, right? When I didn't have a fill command there, it was just black lines because that's the default. When I change it to 100, it got grayer. Let me change it to 0. Sorry, let me change it to 255. And now the lines are white. And in fact, stroke, at least for grayscale, go from 0 to 255. 0 is black and 255 is white. It can be even more interesting than that. We could do something like stroke I. And what we see is the lines fade as they go along. So they go from solid black, the initial lines are black, and then they get grayer as they go out. So I can actually dynamically change the stroke in a systematic or algorithmic way. Okay, questions about that? Let me go back to some figures that actually have interiors, like ellipses. And let me make, I don't even know what'll happen. Let's try making an ellipse here. And let's comment this guy out. So like I said, I don't really know what'll happen if I do this. I could think about it for a while and probably figure it out, but so these are tall, skinny ellipses. That makes sense. I have a 0 here, right? So the width of the ellipse is always 0. So not very interesting. Let's make it non-zero width. Let's make it 5 or something. Okay, so now we've got some tall, skinny ellipses, and the fill color is actually, sorry, the stroke color is actually fading a little bit from black. Let's set the fill color. Let's make the fill color sort of opposite, like 255 minus I, say. So now they start out white with black boundaries, and they go down to black with maybe gray boundaries in a systematic way. Go ahead.
Can you do colors other than whites and blacks?
Yes. Let me just really quickly show you no fill, fill and no fill, and then we'll talk more generally about colors. Actually, you know what? Maybe I'll talk about color next time. I'll leave it hanging out there. You can read about it, and then I'll talk about it on Wednesday. There's a couple more sort of slightly interesting things that you can do with this. Let's play around with random. I'm going to make this canvas a little larger too. What if we make an ellipse with a random center, random number between, say, 0 and 499, and a random number between 0 and 499. And let's make the width just 30. So this is going to randomly place an ellipse of width 30 and height 30. And if I put this inside a loop, what's going on here? The command is exactly the same, ellipse random 500, random 500. But every time you call this random function, you get a new x coordinate, you get a new y coordinate. And by keeping it bounded between 0 and 500, I make sure that the ellipse lands somewhere on the screen. Yeah?
So does it automatically seed the random?
It does. It's convenient that way. So you'll get different random numbers every time. You don't have to worry about seeding like you did in C++. It's sort of the opposite philosophy of C++. So here, the random number generator will generate new random numbers every time you run the program. And if you want to fix the sequence, you can set the seed to something, and it'll always generate the same sequence. But by default, it's going to generate different sequences. You can change the size, right? So let's say I want ellipses between, say, 10 and 30, width and height. And that's actually not going to, that's going to give me actual ellipses as opposed to circles. So all 4 arguments are now random. And I'm limiting the range of the x width and the y width, but other than that, they're random. Go ahead.
I have a question. When you're drawing things, and say you have things that overlap,
Yes.
does the thing that comes later overlap
Yes.
the thing that came before?
Yep. So if I draw an ellipse and then I draw a circle or a square on top of it, it will literally appear that way. So it does happen in order. Other questions? Yes?
How do you change the color of the background?
Okay, so there's a background command that, at least to begin with, uses the same grayscale. So I can set the background to black that way. where I can set it to white. Like that. And if I turn off the stroke, what am I going to see? Nothing. So we'll put the stroke back on. Or we could leave no stroke, and we could change the background to 0. Oh, forgot a semi. In fact, you could make this is a pretty common way of making a star field in a video game. Let's do that. Let's do radius or width equals, oh, can't use that, that's reserved. So we could do random, say between 1 and 5, really small, and we could use that as the width. Like that. We could crank this up to 200. And let's see, forgot to declare that. Int circle width. Still not there yet. Cannot convert from float to int. Okay, we'll just make it a float then. There's a nice little star field. And it changes every time you run it. It's amazing, you know, just what you can do using algorithmic methods to create art rather than paintbrushes or charcoal. I mean, it's really that's really what we're talking about, is a different medium of expression. So we'll talk about color on Wednesday, but until then, I would encourage you to download this thing, start reading through the tutorials and playing around with it.